Imagine a jet so enormous it stretches across 23 million light-years of space, surpassing the length of 140 Milky Way galaxies combined. Astronomers have just made this astounding discovery, revealing one of the most powerful cosmic structures ever witnessed. This is the story of Porphyrion, the largest black hole jet ever found, and how it could reshape our understanding of the universe. Welcome to an incredible journey through the cosmos. Today, we're diving into one of the most fascinating phenomena in space, black holes and their colossal jets of energy. For centuries, black holes have captured the imagination of scientists and enthusiasts alike, not only because of their ability to bend space and time but also because of the mysterious energy they emit. When we think of black holes, we often imagine their intense gravitational pull, trapping everything that gets too close, including light. But in some cases, black holes do something extraordinary. They launch massive streams of energy and matter into space, known as jets. These jets travel at nearly the speed of light, carrying unimaginable amounts of energy far beyond their home galaxy. Recently, astronomers made a groundbreaking discovery: the largest jets ever seen, erupting from a black hole. These jets are a staggering 23 million light-years long. To put that into perspective, that's 140 times the size of our Milky Way galaxy. This astonishing finding is more than just a record breaker, it sheds new light on how powerful and influential black holes can be. At the heart of this discovery is a supermassive black hole, located around 7.5 billion light-years from Earth. What we are seeing now are jets that erupted when the universe was just 6.3 billion years old, about half of its current age. And yet, the energy from these jets is still reaching us today, revealing their immense scale and power. In the upcoming parts, we'll explore how these jets were discovered, what makes them so unique, and what their existence tells us about the universe's history. Don't forget to subscribe and hit the notification bell so you never miss an update on mind-blowing discoveries like this one. The discovery of these colossal jets is not just remarkable for their size, but for the process that led scientists to uncover them. Using the Low-Frequency Array (LOFAR) radio telescope, a team of astronomers was able to detect these gigantic structures, far larger than anything previously observed. The jets were so vast and faint that only with LOFAR's advanced capabilities, which allow it to scan large areas of the sky in fine detail, could they be spotted. These immense jets have been given a fitting name, Porphyrion, inspired by Greek mythology. In the myth, Porphyrion was one of the giants, the offspring of Gaia, and his size and strength were legendary. The name suits these jets perfectly, as they tower over anything else we've observed in the cosmos. This is not the first time this team has broken records in the field of black hole jets. Just a year prior, they discovered another set of giant jets, named Alcyoneus, which span the equivalent of around 100 Milky Way galaxies. However, the Porphyrion jets dwarf even those, stretching across 23 million light-years, more than twice the length of Alcyoneus. But what truly sets this discovery apart isn't just the size. There are three main reasons why Porphyrion stands out from other known black hole jets. Unprecedented scale. As mentioned earlier, these jets are the largest ever recorded, stretching beyond the confines of their host galaxy into the vast emptiness of space, even into intergalactic regions. Tremendous power. The rate at which matter is falling into the supermassive black hole at the center of this galaxy is incredibly fast. This rapid accretion of material fuels the enormous energy output of the jets, making them some of the most powerful we've ever seen. Ancient origins. These jets were launched when the universe was just about half its current age. The early universe was a far more violent and chaotic place, with a lot more activity that could have disrupted the formation and stability of such jets. Yet, Porphyrion managed to survive and maintain its structure over billions of years. The discovery of such a massive system of black hole jets has serious implications for how we understand the formation and evolution of galaxies. While scientists have long suspected that black holes and their host galaxies evolve together, Porphyrion offers new evidence suggesting that black hole jets might play an even larger role in shaping galaxies than we previously thought. These jets, capable of reaching well beyond their home galaxy, likely have far-reaching effects on nearby galaxies as well, possibly influencing their growth and evolution. As we delve deeper into this discovery, we'll explore the immense impact that these jets could have had on their surroundings and what it tells us about the history of the universe. The discovery of the Porphyrion jets doesn't just raise eyebrows because of their sheer size and power, it also opens up new avenues of understanding regarding how black holes influence their cosmic environments. One of the most compelling aspects of this discovery is what it reveals about the relationship between black holes and the galaxies that surround them. Scientists have long believed that black holes and their host galaxies evolve together, a process known as coevolution. But how exactly do black holes, often thought of as consumers of matter and energy, shape the formation and growth of galaxies? The answer lies in the jets they produce. These black hole jets are not just random bursts of energy. They are highly organized streams of particles and radiation that carry immense amounts of energy across vast distances. In the case of Porphyrion, these jets are believed to have influenced the growth of its host galaxy and even neighboring galaxies. The jets eject energy far beyond the galaxy's boundaries, into the intergalactic space, where they can impact other galaxies and the larger structure of the universe. Here's how this influence works. Spreading energy. As the jets move through space, they inject enormous amounts of energy into their surroundings. This energy can heat up interstellar and intergalactic gas, slowing down or even halting the process of star formation in nearby galaxies. Essentially, the jets can choke galaxies by disrupting the very material they need to form new stars. Creating shockwaves, the jets move at such high speeds that they create powerful shockwaves as they interact with the gas and dust in space. These shockwaves can compress gas clouds, sometimes triggering the formation of new stars, or they can scatter material, preventing star formation altogether. Shaping galaxy growth. Over time, the influence of black hole jets can lead to galactic winds, flows of gas that either nurture or hinder the development of galaxies. By pushing material out of the galaxy, the jets may help regulate the growth of the galaxy itself, keeping it from becoming too massive too quickly. What's particularly striking about the Porphyrion jets is that they seem to extend their influence far beyond the galaxy that birthed them. This suggests that black hole jets may have played a much larger role in shaping not just individual galaxies, but entire clusters of galaxies, in the early universe. The energy carried by these jets could have had ripple effects across large swathes of space, affecting galaxies we may not have even discovered yet. Another intriguing aspect of this discovery is how it fits into the timeline of the universe. The fact that these jets were formed when the universe was just about half its current age means they were present during a critical period of cosmic evolution. At that time, galaxies were still forming rapidly, and the conditions in space were more turbulent and violent than they are today. The presence of such powerful jets in this era likely means they had a significant role in the shaping of the early universe. As we continue to study Porphyrion and other black hole jets, astronomers hope to gain a clearer picture of how these energetic outflows influence galaxy evolution and, by extension, the overall structure of the universe. Understanding this process is key to answering one of the biggest questions in modern astronomy: how do galaxies grow and evolve over billions of years? In the next part, we'll take a closer look at the mechanics behind these jets, exploring the complex processes that allow black holes to launch such powerful streams of energy into space. Now that we've explored the impact of black hole jets on galaxy evolution, let's dive into the mechanics behind how these colossal jets, like Porphyrion, are formed and sustained for such a long period of time. At the heart of every supermassive black hole is an accretion disk, a swirling disk of gas, dust, and other matter that the black hole is gradually pulling in. This disk is crucial because it's from this material that the black hole draws its power. As matter spirals toward the event horizon, the point of no return, it heats up to incredibly high temperatures and emits a vast amount of energy. But not all of the material gets consumed by the black hole. Some of it is funneled along the black hole's magnetic field lines, which launch it outwards at nearly the speed of light, forming the jets. However, the process is far from simple. Scientists are still unraveling the exact mechanisms behind these jets, but several key factors help explain how they come to be. Magnetic fields. One of the most important elements in jet formation is the presence of intense magnetic fields around the black hole. These fields act like a giant accelerator, launching particles away from the black hole at near-light speeds. In the case of Porphyrion, the stability and strength of these magnetic fields over billions of years is what likely allowed the jets to grow to such enormous sizes. Accretion rate, the amount of matter a black hole consumes, plays a major role in how powerful its jets can be. The black hole at the center of Porphyrion is accreting material at a very fast rate, meaning it's swallowing huge amounts of gas and dust. This rapid accretion fuels the jets, providing a continuous flow of energy to power them. In fact, the jets of Porphyrion put out trillions of times more energy than the Sun every second, a testament to the immense gravitational force of this black hole. Radiative versus jet mode. What's fascinating about the Porphyrion discovery is that the black hole appears to be in a state known as radiative mode. Typically, black holes in this mode emit energy through winds of particles rather than jets. However, Porphyrion seems to defy this norm, suggesting that even black holes in radiative mode can launch incredibly long jets. This is surprising because jets are usually associated with black holes in jet mode, where they blast out energy in concentrated streams. The fact that Porphyrion's jets were able to form and persist in radiative mode is something that has astonished astronomers and may challenge existing theories about how jets are produced. Longevity and stability. One of the most remarkable aspects of the Porphyrion jets is their stability over time. These jets have been active for around 1 billion years, maintaining their direction and structure throughout that time. This is rare, as jets often shift or die out relatively quickly due to changes in the black hole's environment. The fact that Porphyrion has remained stable for so long suggests that the conditions around this black hole were nearly perfect for jet formation. Scientists believe that the accretion process around the black hole was unusually steady, allowing the jets to grow continuously without being disrupted. Shocking the early universe. The early universe was far more turbulent than it is today, filled with chaotic interactions between galaxies, stars, and black holes. For jets like Porphyrion to persist in such a chaotic environment is a significant finding. Normally, interactions with other cosmic structures would disrupt jets, causing them to change direction or die out. But Porphyrion survived, and this suggests that its black hole had ideal conditions to support the jets over an incredibly long period. This discovery challenges previous assumptions about how black holes and their jets functioned in the early universe. The fact that these jets were able to grow to such enormous sizes during a time when the universe was still young and full of activity raises new questions about the nature of black holes and their role in shaping the cosmos. As researchers continue to study Porphyrion and other black hole jets, they are aiming to understand why some black holes form these massive jets while others do not. The conditions that allowed Porphyrion's jets to grow so large may hold the key to unlocking many mysteries about how black holes interact with the universe around them. In the final part, we'll look at the future of black hole jet research and how new telescopes will help astronomers uncover even more about these incredible cosmic phenomena. The discovery of Porphyrion has opened the door to new possibilities in the study of black hole jets. With telescopes like the Square Kilometre Array, SKA, on the horizon, scientists will be able to explore even more massive jets, uncovering how they influence galaxies and the larger cosmic structure. As our technology improves, we may find jets even larger than Porphyrion, deepening our understanding of the universe's early history. This discovery shows how much there is still to learn about the cosmos. If you're fascinated by space and want to stay updated on the latest discoveries, subscribe and hit the bell icon. Together, we'll explore the universe's greatest mysteries.